Yeah, Deep Space Industries basically came together in May of 2012, at the end of May. I ran into several people that I was working with in different ways. I was working, interestingly, on a book on asteroids, and which we're still working on, but had I written it then, would have been the wrong book, obviously. Universe has a way of making these things happen in their right time. It's interesting, isn't it? But I was able to bring Mark Saunter, who's one of the leading experts on asteroids and mining. He's one of the few people that has the credentials in both fields. And David Gump, who I had worked with in LunaCorp, and Kirby Eichen, who was involved in the insurance world and is chairman of the board, National Space Society, and a few other people. I brought them all into one room and gave them what I call the peanut butter, jelly, and bread, speech. And let's make a sandwich. And the idea with Deep Space Industries is that we are technologically and economically omnivorous, in that this field of play, the development of a space resources industry, is going to take some time to come into being. And so we are structuring our companies so that, yes, we're doing some rather flashy projects coming out of the gate, but you kind of need to do that to prove that you're real, and to get some initial capital flowing into the company. But underneath that, we are looking at a variety of different activities. You'll notice that our company isn't, Asteroid Mining Inc. or anything like that. It is Deep Space Industries. And that is literally meant to be sort of a license to kill in the field, in that we can maneuver our way into different activities. Yes, the harvesting of space resources, prospecting, exploring, harvesting, sampling, processing, and utilizing those resources are really our core business. But the term space resources is fairly wide. This field is going to take more than 5 years, easily up to 10 or 15 years to reach any level of maturity. And by maturity, I mean it's going to take that long a time to get to the point that we are able to really utilize resources in space. Not even bringing them back to Earth in any large scale, but actually in space. Now, the use of resources in space is the niche that we are very much interested in. There are a lot of people that talk about platinum group metals, or there's gold in our hills and things like that. And that's right, but in space, the hills themselves have value. And if you were to step outside right now and scoop up a couple of big handfuls of just dirt, just plain old dirt, a liter of it, let's say. In space, that would be worth, based on current launch costs, easily $10,000 in high Earth or GEO orbit. Even if you reduce costs significantly, cut that in half, it's still $5,000 a pound for dirt. When you start getting into tons, that's some serious money. And again, that's without extracting anything from it. That's just the shielding value. In other words, the ability to protect yourself from radiation by putting a big pile of dirt around yourself. So then once we begin to process those materials, once we begin to utilize space resources in a sense of extracting from asteroid materials the different elements, the different things that we can use, the value goes way up. When we are looking at asteroids, we are looking not just at gold mines, we're looking at oil fields, we're looking at oases, we're looking at the air and sea and rain. I mean, we are looking at what we drink, we are looking at what we breathe, we are looking at what we build to live in. In other words, hydrogen and oxygen, H2O, ice, which is fairly abundant, we believe, in many of the asteroids. If you've got oxygen, you can breathe. If you've got H2O, you can drink. And if you've got hydrogen and oxygen and you put them back together explosively, you've got rocket propellant. So we're both an Oasis and a gas station. Then, once we extract that from the materials, we can pull out things like iron, just using magnets. And once we get the iron, then we can go for the nickel. And once we have the iron and the nickel, we can begin to make things out of that. Now we have the structural aspects of whatever it is we need to do. Or we can make tools, or we can replace parts. And then at the end of the process, while we're pulling out the basics that I've mentioned, we might come across some platinum group metals or some gold or whatever, and now we have those. And then at the very end, we have the slag or sand or dirt or whatever you want to call it. Now from that, we can make glass. So we can make solar panels, we can make the other things you would make out of glass. And at the end of that process, you have something that you can use to make the space version of concrete. Or you can just pack it out there and use it for radiation shielding. So, you know, you literally you literally eat the whole animal, and you utilize every aspect of it. You know, one of the exciting things about space is it really takes us full circle back to this state wherein we need to utilize every aspect of the environment. It's greener than green. You know, we're going back to the Native American idea of using the entire animal. If any resource we find in space, because of the costs of getting there, because of the need to be able to be self-sufficient as completely as possible, any resource we find, we have to use all of it. And so Deep Space Industries is going to be looking at all of the parts of that process. The Deep Space Industries Firefly missions are small robotic probes about the size of 3 laptops. The idea there is to get something out that is as low-tech as possible, and yet combines the very leading edges of our technology in such ways that we are able to save money. The phone I've got in my pocket has more intelligence in it and more capability, for example, the camera that's in it, than they had during the Apollo program and the entire spacecraft. If we can harness those technologies and put them together with some traditional, just basic common sense approaches, we believe that Deep Space Industries can make a huge difference in our ability to explore, prospect, access, and utilize resources in space.